All right, let's jump right in. It's kind of wild when you think about it. Some of the most powerful forces shaping our entire world, the things that literally run our civilization, they're completely invisible. We're going to pull back the curtain on the incredible art and science of taming those forces.
And this is the perfect way to think about it. It's not just a dry science, it's an art form. It's the art of persuading these invisible forces. So every single time a motor spins up, or a satellite whispers data from deep space, or that tiny microchip in your phone just blitzes through billions of calculations, what you're really seeing is something amazing. It's electrons dancing to these ancient fundamental rules, rules that are older than the stars themselves.
So let's talk about this invisible dance. What is it, really, and how in the world does it form the foundation of, well, everything around us? And saying it's the language of modern civilization, that is no exaggeration at all. I mean, just think about it for a second. This is the field that lets us take raw energy and sculpt it into something useful, something that powers our lives. It's how we create these communication channels that connect the entire planet. It's literally the language our modern world is written in. Okay, so this language we're talking about, it's not just one single thing. It's this huge field that's really made up of two different but totally connected worlds. So on one side, you've got electrical engineering. Think big. We're talking about the macro world here, the massive power grids that light up entire cities, those huge, powerful machines and motors, currents so strong they can launch a rocket into space. But then on the other side, you have electronic engineering. This is the micro-universe, a world of tiny, tiny components that operate with the precision of quantum clockwork. And in this world, it's all about signals and information, about shaping them, encoding them, and turning the very idea of information into something we can actually control. So now that we've seen the two sides of this coin, let's go a little deeper. Let's peek behind that curtain and look at some of the truly fascinating, almost magical ideas that make all of this stuff work. And this is where things get really, really cool. Because the deeper you go into electronics, the stranger and more delightful the ideas become. You start to uncover these concepts that are honestly both mind-bending and just beautiful. Take this one, for example, electrons tunneling through barriers they shouldn't be able to cross. I mean, just picture it. A particle hits a solid wall and it just, poof, appears on the other side. It sounds like science fiction, right? But that's a real thing called quantum tunneling. According to the old rules of physics, it's impossible, but electrons do it all the time. And that impossible little leap, it's the whole reason the transistors in your computer's processor can switch on and off billions of times a second. Or how about this one? Resonant circuits that sing at precise frequencies. You know how a singer can hit a certain note and make a wine glass vibrate? It's kind of like that, but for electronics. You can build circuits that are tuned to vibrate or sing at one very specific frequency. And that's how your radio is able to pull your favorite station out of this huge, invisible sea of signals all around us. And that brings us to these electromagnetic waves, which are just weaving across space like cosmic ripples. This isn't some abstract idea. It's the very foundation of pretty much all our wireless tech. Your Wi-Fi, your Bluetooth headphones, the signal to your phone, all of it is just information being carried on these invisible ripples moving through the space all around you right now. Okay, we've talked about all these wild concepts, but what about the people who actually work with this invisible magic every day? What kind of mindset are we talking about here? So who are these people behind the magic? Well, who are the architects of our modern world? It turns out they tend to share a very particular kind of curiosity. Yeah, this is absolutely a discipline for curious minds. It's for people who just love puzzles and spotting patterns. They're the ones who aren't satisfied just using their phone or their laptop. They need to peek behind the curtain. They want to understand that complex, incredible machinery that's humming just beneath the surface of everything we do. And that brings us to our final thought. Welcome to the circuitry. Because when you think about it, all of this stuff, the art, the science, the weird physics, the curious people, it all comes together to form the very circuitry of our world. So here's the bottom line. If you're ready to explore a world where pure maths crashes right into imagination and where physics meets real-world invention, then welcome. That's really what this is all about. It's an invitation to explore the amazing, invisible circuitry that powers our modern world.